I'm still on the center line, so I need to move out a total of 312 thousandths, and I'm watching the digital readout. That's 340 thousandths rather, because I want to leave some material to clean it up. 312 will be the final dimension, so I'm watching the digital readout in the y-axis, and I've got it at 340. So I'm no longer on the center, and that's going to leave an 1/8 of an inch on each side of the center, approximately, for the stem here. Now I'm going to feed in, pardon me, on the x-axis until I reach the 830 mark, and that's when I will start the rotary motion. And remember, I'm on 0 now with the rotary table, 0 degrees. And I'm feeding in now to 830, and I'm watching the digital readout. I'm now at 830, and I will start rotary motion. Rotary table is moving in the counterclockwise direction, as is the hand wheel that I'm cranking. Notice that I'm clearing the clamps there. I probably could take off a little more than what I am in this pass. Now I'm going back to the start position and come in on the other leg. I'm back outside the work, and I'm moving over to 340 thousandths on the other side. That's a minus 340. Lock the table, and I'm coming in this way. Until I hit 830 thousandths on the DRO. I hope you're following this to some extent, and then I can continue the cut this way. Like that, and I'll go all the way around, but I'm going to go back and take a deeper cut now, and I'll have to do this about 3 or 4 times with the roughing end mill till I get down to the depth, which will be about 7/8 of an inch altogether. But I don't want to come into the table, and I don't want the work to break loose from the base piece. I just increased the depth of cut 200 thousandths. some of the chips out of the way. Now you see, I can only go that far, and I'm going to back up again and then come back into this slot. I am now down to my full depth, so this is the last pass that I will make with the hogging cutter. I think you can see why you need to make this in several passes. I just ran into interference right here with that high nut. I knew I shouldn't use that long nut, but I couldn't find a short one, so I got to stop and change nuts or move the clamp. Okay, now I got plenty of clearance there, but notice there's very little clearance here between the nose of the spindle and the clamp. And I ran into that problem on the previous one where I had to extend the cutter. In other words, I can't hold the cutter close to the flutes. It had to be up high enough so that I would clear later on when the cut became deeper. So it's hard to anticipate some of that stuff ahead of time, and that's why I like to do it in wood or scrap before I actually commit myself to the final piece. I need to get one of those Arduino things with a stepper motor. Now back I go to the start and come in from this side. I hope you understand why I have to do this from both directions. I've taken the roughing cutter out and I've got the finishing cutter in there, and it's set to depth. And now in my X, or I should say Y axis, I have it set for 0.312, which was my finishing dimension. And as I move in the X direction, I'll go, instead of 830, it will be 0.812 before I start the rotary motion. And remember that the rotary table itself is set on 0 degrees here on the protractor that goes all the way around. And I've got some lubricant on there because this may be the last finish. It may take another little light pass, I'm not sure. Pretty close fit right in there with the clamp. now I'll come back in from the other side. Okay, the job on the rotary table is done, and it took about an hour. And the dimensions that I'm really worried about was I wanted a 1/4 inch right where the calipers is, and I'm about right on because the scriber is going to be made out of 1/4 inch material, tool steel. And then I know that the hole is 3/4 because I reamed that. The diameter or the thickness of the wall isn't really too important, but I haven't measured that, and because I don't, well, I will now. I wanted it to be 312, and it's about 306, which is just fine. All right, I'm going to take it out. Now, before you take something off of a rotary table or a vise or whatever, make darn sure you're done, because you can never get it back on the same. So off it comes, and over to the bench I go. Just now as the phone rang, I got a package from Speedy Metals, or I should say it came from Speedy Delivery, and it's from Hobby Metal Kits, and it's the steel. And that was so well packed I had a bandsaw to open. Strapped onto a piece of wood, and this is the piece that will be the base. And some other metal I ordered as well, some flat stock. I've got a lot of round stock, but I don't have a whole lot of flat stock, so that will take care of this project. And now, looking at this, I'm reasonably well satisfied. Matter of fact, I'm very satisfied. And it is a difficult part to make, but I thought that you would find it interesting to see one of the million ways to use a rotary table. And that's my new rotary table, the German one, Walters, that you saw me rebuild, or you will see me rebuild in a video. Quite a bit of waste stock here, but you had to have a way to hold it, and this is the way. We still got some material there that could possibly be used as well. So now I'm going to go over to the bandsaw. I'll hold it in a vise so it can't wobble on me, and if this is the blade, I will saw it off. This is how I go about sawing, and I've got a layout line on that. And all the way through until the piece part falls out. And there it is, released from bondage. And now, with the work held in a 3-jaw chuck, I will face it down to approximately a 3/4 inch overall thickness. Not very important. I took a nap and now I'm back, and I kind of forgot where I left off, but I guess I faced this off last. And next I want to drill and tap a hole here for a knob, and I was going to use this knob, but it's a coarse thread. These are just knobs I got out of my junk drawer, but I think that this little knurled one looks better, and it's a fine thread, which is what I really wanted. So I have laid out a hole, and I will drill that number 3 and tap it 1/4 28. That's National Fine, Unified National Fine. Now, when I went to fit this up, it was too tight. So I really needed about 1/1000th off there, so I had an adjustable reamer. And this one is marked 3/4, so it's just set at a little bit over, perhaps 751. And putting this in the vise and turning the work against it, it cleaned up just enough to where it fits nicely. And I like this kind of reamer. It's marked 3/4 as opposed to this kind of adjustable reamer, which adjusts throughout quite a large range. So I didn't even realize I had this one, and it happened to be adjusted just right. And then one last thing, this is too thick here, so I will mill it down So it is the same thickness as this, which was 5/16. I'll take it over to the milling machine and mill that off, and I marked X as the part that I wanted to remove. Did you ever cut the wrong part off and spoil the work? So that's why I put the X on there. Alright, that's enough for today. I went from this to this to this to this, and finally that's the finished product. And the scriber will go on there something like that, or is it like that, with the and I have to make a clamp like this also. But tomorrow I'll get started on another part. See you then. Well, it's a new day. I'm all fresh, full of energy, ready to go. I had 3 cups of coffee, so bear with me. Continuing now on the semi-accurate, semi-precision height gauge here. Let's get the nomenclature right. This is the base, this is the post, and I'm going to call this the slide and the scriber and the clamp and the scale. And then we got some thumb screws and other miscellaneous parts. And in review, I have already completed the post, and I may cut this off. And I have completed the slide, and now that the material came in the mail yesterday from Bernie at Hobby Metals, and that piece is about $9. It was 6 inches. You have to order 6 inches or 12 inches. Look at how nice and clean that is. It's just cold roll steel, 1018. It's not tool steel, but all the corners are deburred and so on before he ships anything out. So let me get this laid out, and it's a little too wide, and I'm modeling it really off of this base, so I'm going to take off about 1/4 inch. I'll lay that out and talk about it here in just a second. There will be no published drawings on this, so if you're interested in this, kind of make notations of some of the dimensions that I give you as we move along. The base is to be 1 3/4 wide, 3 1/4 long. It's 3/4 thick. Now I've already laid it off with a square, 3 1/4. So with the height gauge, I'll mark that. Now I'm going to go over and saw this out, which is rather laborious on thick stock like this. Then I'm going to take it to the mill, and I will mill both ends with the side of the end mill to square it up. And I don't care too much about the overall length if it varies a little bit from that. And then I'll also have to mill the saw line there after that's sawed off. I think I'll stop and give you a progress report here, and I'm fully aware that I repeat things from video to video, but then there's always somebody new that never heard of me until today, and this would be new to them. So I've milled off both ends, and I've been sawing here, and I quit as I noticed. Remember, this is cold roll steel, and there's tremendous stresses in here, like my fist. And so the kerf right here is, I've done this before, approximately 40 thousandths where the red line is, and it has spread up here to, way at the end here, to 60 thousandths. You might have observed that in wood sometimes too, but that is the stress being relieved. And most of it is being relieved on the skinny side. So in effect, this edge here probably is not totally true anymore. But for my purposes, it could not matter less. I'll finish sawing this off, and then I'll be over at the milling machine, and I probably could have been done by now if I just used a roughing end mill and took that down, reduced it to chips rather than sawing it off. And now I'm milling it down to the line. It's milled down to width, and I laid a center line out so I could lay the hole out. And looking at this piece, the hole is, the center of the hole is a 1/2 inch from the end, so with the height gauge set at half. See how nice it is to work with a height gauge? I'll center punch that, and I'll be over at the milling machine now, and I'm going to do all the milling, and it will be a 3/4 reamed hole, so I got to work up to that, kind of like I did on this piece, be the exact same procedure. And you could choose whether or not to go all the way through. I think I'm going to go all the way through, because when you ream to a blind hole, the full diameter is not achieved because there's a bit of a taper on the end of the reamer. So I'll go all the way through. I have to set it up on parallels in order to do that. One of the annoyances on a Bridgeport mill is raising the knee up and down, and especially for long tools like the reamers and so on that I'm going to use. So I'm going to use my relatively new lithium battery DeWalt here, along with the crank adapter here. You've seen me make that in other videos. Okay,